Hello everyone, welcome to LX518. Today I'll be sharing a topic on how to set up a load test for a power supply. If you have an old or unknown power supply sitting in storage and you want to check whether they are still functional, this tutorial will guide you through the process. Conducting a proper load test is essential to ensure the power supply is working as expected and can deliver the required voltage and current safely. In this session, I will walk you through the steps needed to set up a load test, explain the tools required, and highlight key safety precautions to take during the process. So stay tuned, all the details are coming up right now. Alright, so for the background, we recently found a so-called lamp power supply in our storage room. The markings on the unit indicate the following specifications. The input is 220 VAC and the output is 380 volts DC with a maximum of 1 ampere current rating. At first glance, the power supply appeared to be in good condition. We conducted a visual inspection of both the exterior and the interior components, and there were no obvious signs of damage, such as burnt components, loose connections, or corrosions. However, since we had no prior knowledge of its operational status, we could not be certain whether it was functioning correctly. To verify its performance, we decided to conduct a load test. However, before proceeding, we needed to create a suitable dummy load that could safely handle the power supply's output. In the next slide, we will walk you through the steps to design and build a dummy load for testing the lamp power supply. You can also apply these steps to test your own power supply. Thank you. Alright, so the lamp power supply we have has a unique voltage output of 380 volts DC. To test it, we need to design a combination of high power resistors to create a dummy load. First, let's review the lamp power supply specifications. The voltage output is 380 volts DC. The current capacity is 1 ampere. The power rating, of course, by the formula P equals to IV. So 380 volts times 1 ampere equals to 380 watts. So we need to take note these values. Alright, so by Ohm's law, R equals to VI, voltage over current. So 380 volts over 1 ampere equals to 380 ohms. That would be our R. This means we need a 380 ohms resistive load to test the power supply at its maximum capacity. So let's design the dummy load accordingly. To achieve a total resistance of 380 ohms, we connected multiple 25 watts resistors in series as follows. So we have 20 ohms, around 18 quantity, so the total resistance is 360 ohms. And we have 2 quantity of 10 ohms, so equals to 20 ohms in total. And 18 times 25, of course, is 450 watts, and 2 times 25 for the 10 ohms resistors equals to 50. So in total,
we can get 380 ohms with 500 watts power capacity of resistive load. So we are good because the lamp power supply maximum power capacity is 380 watts only. So our resistive load based from our configuration, from our calculation, is 500 watts, right? This setup ensures the desired full load test resistance and power rating while maintaining the efficiency. To make the assembly more presentable and organized, I enclosed the series connected resistors in a casing and labeled them properly. This is not only to enhance the overall appearance but also makes it easier to identify the configuration. Overall, this was a simple and effective way to achieve the required resistance while keeping the design neat and functional. Alright, I will give you another sample illustration. Let's say we're going to design a dummy load for a 12 volts power supply with 2 amperes current capacity. So first thing that we need to do is to calculate the power based from the voltage and current information. So we have current of 2 amperes, then voltage output of 12. The power capacity of our 12 volts power supply is 24 watts, right? The next thing that we need to do is to calculate the RL, which is the dummy load resistance. Alright, so by Ohm's law, so voltage over current, so we have 12 volts over 2 amperes, so we can get 6 ohms that we need for our RL to test our 12 volts power supply for a maximum capacity, right? So based from suggestion, the resistor that we need to make for our dummy load must have a power RL greater or equal to 150% of our P. So let's say we have a 24 watts capacity of power supplies, or our dummy load must be 150% higher than that. So from the example, we should find a dummy load of 54 watts or higher, right? Okay, so let's say we found 3 resistors to get the 6 ohms. So let's say we have R1 equals to 3 ohms, and we have R2 equals to 2 ohms, and we have R3 1 ohm. So let's say R1 is 30 watts resistors, and R2 is 20 watts, and R3 is 10 watts. Alright, to calculate the total resistance, so we need to add all the resistors because they are connected in series. So R1 plus R2 plus R3 equals to 3 plus 2 plus 1 equals to 6 ohms. So it is it's good to test the maximum capacity of our power supply, right? So the power, also we need to know how much is the capacity of our dummy load resistors. So to get the overall power capacity, because they are connected in series, so we need to follow same like resistor. PR1 power R1 plus power of R2 plus power of R3. So based from our example, we have R1 equals to 30 watts, R2 is 20 watts, and R3 is 10 watts. So the total is 60 watts. Good, because our power supply capacity is 24 watts. Our dummy load capacity is 60 watts, so it is good to go. And maybe it is also good to calculate the voltage drop for each resistor, right? So for VR1, since we have 2 amperes current, our configuration of dummy load is connected in series, so of course all current that go through this R1, R2, and R3 are the same. All load connected in series must have the same current. So we're going to use the 2 amperes, right? To calculate for VR1, 2 amperes times 3 ohms, so it's the voltage drop across VR1 is 6 volts. Same goes to VR2, VR3. So we can get for VR2 is 4 volts, and for VR3 is 2 volts. So the total voltages across these resistors is 12 volts, right? And then let's calculate also the power consumed by each resistor. So we're going to use I squared times resistance. So for power in R1, we have 2 amperes times squared times 3. So we get 12 watts. And same goes to PR2 and PR3. For PR2, we have 8 watts. And for PR3, we get 4 watts. So the total power consumed by these 3 resistors, of course, is 24 watts. Alright? So that's it. I hope this information is helpful for anyone looking to build a similar setup. If you found this useful, don't forget to like and share and subscribe to my YouTube channel for more tutorials, tips, and project updates. Your supports helps me create more content like this. See you in the next video. A school!